Hello and welcome to another Spaz Gamer tutorial. Today I'm going to be teaching you a little bit more about how to develop games in Lua with Love2D. We're going to actually add some gameplay this time and add some enemies that our player can shoot. So in the last tutorial I showed you how to run Love on your project from the command line. However, that's a little bit confusing and may cause some difficulties for certain users, especially Windows users. So I'm going to show you quickly how to set up your project in ZeroBrain Studio, which if you haven't already installed, you should check out the video. I'll have a link in the description how to set it up. So it's very easy to get set up in ZeroBrain. All you have to do is go to Project Directory, choose, and then select the folder or directory that you have your project stored in, if you created it in the last tutorial. If you didn't, you can just start from a new project. So if you try to build it immediately, you may have some trouble because it's using the default Lua interpreter, which doesn't support Love. So what we have to do is just change the interpreter from Lua to the Love2D interpreter, which has to point at the application in your system. And once it's working, you can just hit the little green button to run and build the project, and it will work when you run it from scratch. If your Love2D isn't in a standard location, you can add it to your... You can configure ZeroBrain to know where it is by going to your preferences. So go to Edit, Preferences, Settings User, and just set path.love2d equals, and then you put the path in here. So now that we've got our configuration out of the way, let's actually write some code. So let's start by creating an enemy table. This is because we need to have some kind of storage for our enemy, and we're going to have multiple enemies, so it's going to be slightly different than the way we've written the player. So like the player, we'll have an X location, a Y location, a bullets table, a cooldown, and a speed. So let's copy all those. And instead of player, we'll just set it to enemy. At least copy and paste. Enemy. Okay, so now that we've got those out of the way, we'll set the Y location to 0 because we don't want it to spawn in the same location as the player. And then the bit where it changes is actually the code to make it an enemy fire. So instead of putting it in a function like we have here, inside via variable assignment, so player.fire, we're actually going to create a function outside. So in this case, it's going to be function enemy :fire end. Alright, so this little colon here is actually a simpler way to write enemy.fire self. And what self is it's a reference to the function that we call it on. So it's a reference to the table that we call it on. So if we call enemy.fire later on, enemy:fire later on, it'll pass us self. The self variable inside of here will be the enemy that called fire. So instead of every enemy firing every time we call the fire function, we can individually allow each one to fire. So I don't think we need to pass anything to it. It has access to all its internal things via self. So self dot cooldown. Oh wait, yeah, so it's actually just this bit right here. Copy it and paste it. And where we say player, instead of placing enemy, which is a reference to only one variable, we can say self, which will make it general purpose and allow us to use it anywhere. This may sound a little bit confusing right now, but we'll see why in a minute. It's a bullet equals self.x, self.y, and self.bullets is going to have bullet appended to it. Also, we're going to create a table called enemies because we want to have multiple enemies. So we'll probably have to create an enemy spawn enemy function. Actually, we might as well do that right now. So function enemies spawn enemy end. So this will create an enemy, and we can just copy, put our code in here. Enemies controller, let's name it, and enemies controller dot enemies is going to be our table that has all the enemies in it. So enemies controller, use tab complete because it makes our lives a little bit easier, and then self dot enemies equals actually we're gonna have to use table dot append, table dot insert, and we're gonna insert into our self dot enemies table enemy. So once again, self dot enemies is just enemies controller dot enemies, because self is just a name for enemies controller as long as we're inside this enemies controller colon spawn enemies function. And that colon is important. You can't use a dot there, otherwise it doesn't implicitly pass self. Otherwise you have to say self here. You have to actually pass it. Okay, so right now it's not going to do anything new because we haven't added the logic to create an enemy. So let's actually create one in our initialization function. So enemies controller spawn enemy, like so. Now we have an enemy in position 0, 0. Now we may want to change this in a minute to allow us to create an enemy anywhere in space, because otherwise it will create them all in the one corner. But at the moment this is fine because we're just gonna hope that one enemy shows up. So if we build it, we get an error. 22 enemies controller is a nil value. 22. Ah, yes, because this has to be created outside of the function because love.initialize isn't called before this function is attempted to be created. So if it tries to get created before the table exists, it's gonna think it's nil, and then it's gonna blow up. So if we just move this outside, it's fine because it'll create it at the right time. So let's build it again. And enemy is a nil value as well. So enemy is a nil value. So we just have to create an enemy table up above, even though because this is just kind of our class. It's like a placeholder for now. It's not actually ever going to be created as an entity in the game. So there we go, it worked, didn't blow up, but we don't have any enemy appearing on screen, and the reason for that is we haven't added it to our draw function. So let's do that. So we're just going to do a little for loop for in let's say E in pairs. Which table is it? It is our enemies controller dot enemies table. Do love dot graphics dot rectangle, and we're gonna say fill, and it's gonna be the x location, the y location, and our width and height. Let's just set it to the same. Alright, actually that's the same width as a bullet. Let's set it to our player because we already used some other things that were the size of the player. Alright, so now if we run it, there we go, we've got an enemy showing up in the top corner. So he doesn't do anything at the moment, and he's the same color as the player. So the first problem we can easily fix. Let's just make it a different color. We'll make him red, so it's obvious that he's not the good guy. So red is 255, 0, 0, 0, because this is red, then green, and blue. So if we set red to 255 and the others to 0, green and blue to 0, it's of course going to be red. So if we build this now, we get our red enemy. And let's make our enemy move a little bit. In Space Invaders, they move in kind of a zigzag pattern downwards. So you could simulate that with a sine wave. But that's like the simplest way to do it. But for now, let's just have him move straight down because it does. We'll add that bit later. So in our love.update function, we're gonna say for v in I pairs. We can do pairs actually. It doesn't really matter. We don't care about the index of each thing right now. So for that, in pairs of enemy controller dot enemies, we'll just say, actually let's use E instead of V because E means enemy. Oops. And E dot Y equals E dot Y minus 1. So now they should just move down. Or up in this case. That's wrong. We have to add 1. Because Y positive is actually downwards. So there we go. Our enemy is moving downwards. So let's add multiple guys on screen. We'll say let's just add 2 for now. Maybe we'll randomly spawn them later, but for now we'll just add 2. So we'll spawn 1 enemy. So we'll spawn 2 now. And if we build this immediately, like I said before, they're both in the exact same X and Y location, so we'll still only see 1 rectangle. So when we spawn enemies, let's add the ability to set their X and Y location. So back to our enemy's controller spawn enemy, we're just going to say X comma Y in our arguments to pass an X and Y location. So then X and Y here, which means it'll just grab the X location, pop it in enemy.x, Y location, pop it in enemy.y, push it to the enemies table, and then when we draw it, it'll be in the new X and Y location. So we'll have our first guy spawn at 0, 0. Our second guy spawn at 40, 0. Now when we build, we see 2 rectangles that are extremely close to each other, so it looks like 1. So let's make it a farther distance. There we go. So there we've got a little bit of a gap now, so we can see the difference between the two. Alright, so I got a request in the comments to teach how to load graphics, so I guess we should add that before adding collision detection, because collision detection is a little bit more intensive and confusing, so we'll probably get to that in the next tutorial, but for now we'll just add some graphics to make it look nice. So first of all, we need to have some kind of pixel editor or graphics editor of any type. If you've got Photoshop or GIMP, you can use those as well. I have Pixin, which is a little editor for Mac. It's a pixel editor for Mac. And we'll just create something reminiscent of the original Space Invaders. So even though it doesn't show up in our project outline thing, it is actually here. Oh, there it goes. It just takes a little while to refresh. So it shows up there eventually, and we have our PNG in here now. So what we can do is load it in at the beginning, because we don't want to load the image every single frame, otherwise we're going to use up all our system resources, because every time we load the image in, it sticks it in memory. And if we load it in a bunch of times very quickly, as it would if we loaded the image every frame, it would cause our computer to slow down and possibly even crash our game. So we definitely don't want that. Whenever you load images, always be sure to load them at the beginning. Whenever you load any kind of resource, actually, you want to load it at the very beginning, before the game starts, or during the initialization, or before the level starts. You never want to do it more than once. So we can do this in our love.load function, and what we're gonna do for now is just load it in for our enemies. So let's say the other issue is every time we spawn an enemy, we could load the image, or we could load it and then have every enemy point to that image. So we're gonna do that. We're gonna say enemies controller.image. So this will be our global image that all our enemies use, equals love.graphics.load, love.graphics.image, I'm sorry, image, and we'll say enemy.png because it's in the exact same path. So if we build it now, just to make sure we didn't do anything stupid, it shouldn't crash. Ooh. Graphics new image. Sorry, new image. And that love.graphics.new image, we haven't set it to anything yet though, so we have to draw it still. So in our draw function, instead of drawing a rectangle, we're gonna say for our enemies inside this loop here, we're gonna say love.graphics.draw, and in here we fill in. Instead of this string fill, we're gonna put the image that we want to draw. So enemies controller.image is the image we want to draw for every enemy. We don't need to set the color anymore, so we just set it to 255 so it doesn't mess with our image. So if you set it to pure white, whatever the image draws will get drawn on the screen instead of being tinted by whatever previous color it is. And instead of setting the width and height here, we'll come back to that in a minute, but for now we'll just leave it like this. And there we go, we see these little terribly drawn green squids falling down from the screen. So now we can actually add these widths so they're a little bigger because they're kind of tiny at the moment. But when we do that, they're rotated and funky. So the reason for that is this first value is actually the rotation and not the width, so it's 0. The love.graphics.draw function is the image, then the x, y location, the rotation, the width, the height, the skew, and the skew x and y, which you never are going to use, so I don't ever even go out that far. But these final values are optional, so that's why we can leave them out. If you only set the width, it'll set the height to that as well. So we're just going to do that for now. That looks terrible and is way too big, so we'll set it to 10. And then these will be 100 pixels long because it takes the initial width and multiplies it times this width that we add. So that's still a little bit big, I think. We'll say 4 times the size, 5 times the size. And that's looking closer. So this looks like crap right now because these guys are being they're way too small, but they're trying to be Love is trying to interpolate and make them look better by when you scale them up, and it doesn't look good with linear interpolation and pixel art. Pixel art is using constant interpolation, which will look very pixely, which is what we want, but if you try to scale other images with it, it sometimes looks bad. So the blurring is just the default behavior, and we can change that. So we can change that if we go to the love.load function, or really anywhere. You can just say set default filter. It's changed between versions, and we're going to set it to nearest for the min and nearest for the max. So when it makes things smaller, they'll use nearest interpolation. This one could be actually set to linear and we wouldn't notice, But this one, the max definitely has to be set to 2 nearest, because when you scale up, you don't want the linear interpolations trying to smooth things out. So now when we build it, maybe we have to set this before here. Yeah. So you have to set it. So you can't put it anywhere. You have to put it at the very beginning before you load any image resources. But once you do that, it won't look like crap when it loads, and they'll actually be sharp as they should look. So we could do the same thing for the player. So for our player, we'll just draw a little spaceship of sorts. We can do the same thing for the player, and say player.image equals love.graphics.new image, and once again it's just going to be player.png. And I'm going to set the scale rather than for each image individually, because otherwise we'll have to set the scale for each one. We'll actually we'll say set width, set scale of.graphics.scale, and we'll scale it to 5, so that way it'll scale everything 5 times as large as the images. Whoops, I screwed up some. Player 14. Yep, I messed my Y. So now it'll scale everything up 5 times the amount. It actually scales up the entire game. It scales the axes as well. So 20 is now 100. 20 pixels apart is now 100 pixels apart. So you just have to change that. But if you set it early on, it's not quite as much of an issue. So now it's love.graphics.image for our player instead of a rectangle. No, sorry, love.graphics.draw, and we're going to say player.image. We don't have to set these anymore, the width and height. We'll move our set color up so we don't have to call it twice, which makes things a little bit faster, even though it's not really that noticeable. It's just one less call. And if we draw it immediately, as I said before, our transform operations are off. So we have to reset our player's location to be 5 times smaller than what it originally was. So if we set it to 110 now, we get it at the bottom of the screen, which moves really fast because the speed has to be much slower now. So we'll set it to 2, and we'll set our enemy speed to 2. So there we go. Our bullets are screwed up as well, so let's fix that. So bullets will be spawned. You just take everything and divide it by 5, really. That's all you have to do. If we scale it by 5 and divide everything else by 5, it'll just result in being the same relative location as it was previously. Take 35 divided by 5, which is 7. And the bullet scale is going to be smaller now, too. So it's going to be 2 pixels. Okay, and their X and Y locations are a little bit off because it's not exactly using the player's X and Y's locations now. So player.x, player.y. This is just going to be a little bit of trial and error here. There's a lot of that in game development actually. So we'll say 5. That's more lined up now. Actually, maybe 4 even. Yep, that looks better. Bullet speed is going to be slower now, which is when we update our bullets. So b.y equals minus b.y 10. So instead that's going to be divided by 5, which is 2. And then our bullets are a little bit slower. And then lastly, we can just get it to line up with the barrel of our player's gun a little bit more. Oh, because we have to add, because we're trying to make it lower. There. And I think if we get one more pixel down, maybe even another. Alright, there we go. Looks pretty cool now. So in our next tutorial, we'll actually add some collision detection, which is a heck of a lot of fun. So prepare yourself to be confused, because the logic for it is a little confusing. I'll have some diagrams to help visualize it a little bit, which should help out a little bit. But that's going to be our next big thing to tackle. So thank you very much for watching. I hope you enjoyed. Make sure to like, favorite, subscribe. Let me know in the comments if you want to see anything specific. Like this week it was the graphics, but next week it could be something else. Some of the more complex things I probably will pass over in this series, since this is supposed to be an introduction. But if you have a specific question about this game engine or some feature you want to add to the game, make sure to let me know, and I'll be happy to at least address it in the comments or in the next video. So thank you very much for watching. We will see you all later.